In one of my previous videos called Batos Coaxial Quarter Wave Notch Filter, video number 2, I have demonstrated a coaxial cable notch filter, which is something like this, made out of coaxial cable. So basically today I'm gonna add and make a video number 2. And that would be, okay, in a previous video I only had one filter. So we got the RF in, and if you look at it very carefully, let me just try RF in, which is that particular point, okay, and then we got the RF out, okay, going into wherever the instrument that I'm gonna feed, and then of course we got our quarter wave stub over here. That's a single filter, and we saw it does give a and very sharp attenuation, and it's a very good filter, and not so difficult to make. However, what would happen if I actually put two filters next to each other, something like this? In other words, if I do take another filter, let me just try to zoom out. Okay, so say I add a filter over there, and then I have got now two filters. Okay, so let's see what happens first with one filter. Okay, okay, sorry, it's a bit difficult with two hands to control the camera and the cabling. All right, now we got the spectrum analyzer. Okay, now let me zoom onto it. And then let's see, okay, too much, okay. All right, now my reference signal coming out of my portable sweep generator up to 3 gigahertz, 3.6 gigahertz actually, and let's see, yeah, it gives me the reference of minus 42.8 dBm. Okay, so our starting point would be minus 40 reference signal, minus 42.8 dBm. We're going to be feeding into the input of our notch, say single notch filter, and then see what sort of signal do we get on the output of the notch filter. All right, let me just put the camera down again and then try and do it. Okay, now let's see. So we remove, okay, the actual thing. Now we take a notch filter, we plug the input and the output of the notch filter, we plug into the spectrum analyzer. And if you look at it very carefully, you will see, okay, there we go, okay. All right, it's more or less in focus. So now from minus 42.8 we are getting a notch on this filter. Now let me just try and sorry. Okay, there we go. All right, so now, and we are right on 145 megahertz right in the center. For argument's sake, I would like to attenuate radio amateur signal on my FM radio, or interfering with my FM and so on. Okay, of course the notch filter can be applied for many, just about any frequency. So now let's go with the marker, okay, and see on the scope. I'm just driving it down, just to see what attenuation we have achieved. Now if you look at it very carefully, let's just see, let me just position it. Okay, so now you can see that this filter, okay, I've got the generator, okay, zoom it out. Okay, so now basically from the generator into the actual notch filter. Here is the input. Here is the input. Here is the input. Here is the notch filter. Actually, I just put it with cable ties together. Okay, and that's a notch filter. And then, of course, we got the output out of the T-piece going into the spectrum analyzer, which is this one here. We are getting up a minus 14 dBm, 14,8 to be precise. So we say, okay, so we are attenuating from 42,8 to minus 14,8 dBm. So what is our attenuation? So if I take a calculator and I say minus 42,8 minus 14,8, that gives us exactly 28. So it's a minus 28 dB dB attenuation that we're actually getting with the single filter. Okay, so now what would happen if okay, I'm just removing the filter now. What would happen now if I actually put a second filter in line? Okay, let me do that. And then see what happens, how much attenuation we will get. So what I'm going to do is the output of one goes into the input of the other. Okay, I'm still going to plug it in there. Okay, I will show you now. And then I plug on the input of both filters. So now basically we got generator signal coming out into one filter with one sort of quarter wave stub, and then again going into a second input of another sort of a quarter wave filter with the quarter wave stub here, and the output into a into the what do you call it, into the spectrum analyzer. Now let's actually measure and see how much signal we have attenuated at. With single one we got achieved minus 28 dB attenuation, but let's see with two. Okay, let me just zoom a little bit. Okay, again I'm just sort of driving the, okay, oops, overshot. Okay, now I don't know if you can see the cursor right over there. All right, so now what are we actually getting on the scope? Okay, now we're getting minus 10 at that particular point, in other words from our reference, which was minus 42,8 somewhere over there. Okay, we have attenuated with two filters to minus 10 dB, 10,8 dB. So now with two filters it's minus 10,8 dB. So if we say minus say 42,8 minus 10,8, it gives us actually something like 32, minus 32 dB. Okay, which is quite a bit. Okay, let me just put this paper over there. Okay, so minus 42 or reference, if you subtract a minus 10 dB, 10,8 dB, okay, we get actually minus 32 dB attenuation. And minus 32 dB attenuation would be something like plus minus, I would say about 2,000 plus, actually 2,000 times more, or well, 2,000 times whatever signal we're feeding here, the signal on the output of the second sort of notch filter would be a minus 2,000 times smaller, 2,000 smaller than the actual input. So we can actually see that there is a beneficial sort of result, you know, from adding the actual two notch filters in series. And they can be as close as possible. It's really immaterial. Of course, there is a different technique that we sort of can apply, and that will be sort of demonstrated in a video number 3, where if you want, say for example, I was getting with a single filter minus 28 dB attenuation, and if I want to double it, say to 40, 50, 28 times 2, that's 56 dB. Then I would use a special technique, again with the 2-notch filters, but with a special insertion of a quarter wave sort of in between the 2 actual notch filter, extra quarter wave over here. And then I will do that in video number 3 next time in a video number 3, as I said. Yeah, on that note, I've just demonstrated 2-notch filters connected in series, and we are getting something like about extra sort of attenuation. Usually one gets anywhere between 6, maximum 8 dB attenuation with the 2 filters added together. And with the new technique, anything up to double. Alright, on that note, thank you for watching Batos 2 quarter wave filters in series.